Hi, what's up friends? It's Scott from Japan. Today is August 15th. Time for book reading. I'm on summer vacation. I'm in Oga Peninsula in Akita Prefecture in northeastern part of Japan. It's raining very heavily outside at 7 o'clock. It's a little too early for breakfast, so I'd like to do some reading before I get hungry. So today I'd like to read a book entitled Experiments with Heat. So here we go. Why do people sweat? Have you ever been outdoors when the temperature was higher than 100 degrees Fahrenheit or 37 degrees Celsius? If you have, then you probably did not feel like doing much except look for some shade. Even in the shade, you may have been sweating because it was still hot. Sweating is the body's way of trying to keep cool. About 200 years ago, a scientist performed an interesting experiment to show what sweating can do. The scientist took some friends, a dog, and a steak into a room. The temperature inside the room was kept at 126 degrees Fahrenheit or 52 degrees Celsius. After 45 minutes, everyone came out of the room. They were all fine, including the dog. The steak, though, was cooked. The people and the dog were able to keep their bodies cool enough. The people by sweating and the dog by panting. Sweating causes drops of water to collect on the skin. When it's hot, these water drops evaporate from the skin. As the water evaporates, the skin becomes cooler. Normally, a person loses about 1 quart of water in a day through sweating. This must be replaced by drinking water or other liquids. If the water is not replaced, then the body cannot sweat. If the body cannot sweat, then it cannot get rid of something that is building up inside. Heat. What is heat? Heat is a type of energy. What do you think of when you hear the word energy? Perhaps you think of a person who is very busy or very active. Scientists think of energy as what is needed to make something move or do some type of work. As a type of energy, heat then must be able to make something move. What can heat move? Experiment 1. Moving molecules. You will need several ice cubes. Place the ice cubes in your hands. Notice what happens as heat from your hands warms the ice cubes. It's no surprise that the ice cubes melt and then turn into water. What does this simple experiment show? That heat is a type of energy. As you know, an ice cube is just frozen water. Water is made up of very tiny bits or particles. These particles are called molecules. The water molecules in ice stay pretty much in place as long as it is cold. These molecules do not have enough energy to move around. Heat gives these molecules energy. This heat comes from your hand and from the air in the room. Once this heat supplies enough energy, the molecules in ice can move away from each other. When the molecules move far enough apart, ice turns into water. If just a little heat can make molecules move, what happens if you supply even more heat? Experiment 2. Moving faster. You will need 2 identical glass jars, refrigerator, adult helper, pot, stove, oven mitts, large plate, food coloring. Fill 1 jar halfway with water. Place a jar in the refrigerator so that the water gets cold. While the water is cooling, ask an adult to heat some water in the pot. The water should be hot but not boiling. Ask the adult to fill the other jar halfway with the hot water. Use the oven mitt to place a jar with hot water on the plate. Take the jar of water out of the refrigerator and place it next to the one with the hot water. Add 2 drops of food coloring to each jar, but do not stir the liquid. Watch what happens in both jars. The hot water has more heat than the cold water. The more heat there is, the more energy the water molecules have. The more energy they have, the faster the molecules move. So molecules of hot water move faster than the molecules of cold water. Because the molecules of hot water are moving faster, they bump into each other harder than molecules of cold water do. Like water, food coloring is made up of molecules. Molecules of hot water also bump into the food coloring molecules harder. This causes the food coloring molecules to spread out faster through the hot water. You have learned that heat makes molecules move. As a type of energy, heat is also able to do work. Heat is used in power plants to produce electricity. We use this electricity to do many things, such as powering our computers and turning on lights. Where does heat come from? If you have ever been outdoors when the temperature was over 100 degrees Fahrenheit, 37 degrees Celsius, then you know how much heat can come from the sun. What else can the heat from the sun do besides make you feel hot? Experiment 3. Cooking a hot dog. You will need empty shoebox, aluminum foil, nail, unpainted wire, hanger, liquid soap, adult helper, pliers, scissors, hot dog. Line the shoebox with aluminum foil. Use a nail to poke a hole in each end of the shoebox slightly below the middle. Wash the hanger with soap and water. Ask the adult to use a plier to straighten the hanger. Bend the end of the hanger to make a crank with a handle. Poke the straight end of the wire through one end of the shoebox. Carefully push the hot dog through the wire, then poke the other end of the wire through the hole at the other end of the shoebox. Place your solar cooker in bright sunlight. Every now and then turn the handle so that the hot dog cooks evenly. Try toasting marshmallows using heat from the sun. Where else can you get heat besides the sun? Experiment 4. Releasing heat. You will need large foam cup, hydrogen peroxide, plastic spoon, quick rising or fast acting dry yeast. Fill the cup halfway with hydrogen peroxide. Add one spoonful of the yeast to the cup and stir. Watch the contents inside the cup for 5 to 10 minutes. Can you see tiny bubbles of gas coming to the surface? How does the bottom of the cup feel? Yeast breaks down hydrogen peroxide to make new substances. When new substances are made, a chemical reaction has taken place. One of the substances made in this chemical reaction is oxygen gas. The tiny bubbles you saw were filled with oxygen. Besides making new substances, chemical reactions can also give off heat. Did the bottom of the cup feel warm? This happened because heat was given off by this chemical reaction. Most power plants get the heat they need to make electricity from chemical reactions. These power plants burn fuels such as oil and coal. Burning is a chemical reaction that gives off heat. Not all chemical reactions, however, give off heat. Some chemical reactions take in heat. Besides being given off or taken in, what else can happen to heat? Experiment 5. Conducting heat. You will need adult helper, wire cutters, tape measure, metal coat hanger, sandpaper, thick copper wire, in parentheses, used by electricians, cutting board, aluminum foil, paper clips, candle, matches, pair of oven mitts. Ask an adult to help you cut a 12-inch or 30-centimeter piece of coat hanger. Sand off any paint or coating on the wire, which is made of iron. Cut the 12-inch or 30-centimeter piece of copper wire. Use pliers to twist the ends of the iron and copper wires together. Cover the cutting board with aluminum foil. Place the wires on the foil. Place 3 paper clips on the iron wire and 3 paper clips on the copper wire. Ask an adult to light the candle. Hold the candle so that the wax drips onto the paper clips and over the wires. As the water cools, the paper clip should stick to the wire. Use the oven mitt to hold the wires over the candle flame. Watch what happens to the paper clips. Heat from the candle flame passes along the wires. As it does, the wax melts between the paper clips to drop. Which paper clips fall off first? The paper clips should start falling off the copper wire first. This happens because heat travels faster through copper than it does through iron. The heat reaches the wax on the copper wire sooner than it reaches the wax on the iron wire. The wax melts sooner on the copper wire, allowing the paper clips to fall. Copper is said to be a better conductor of heat than iron. What is temperature? When you go outdoors on a sunny day in the summer, you can tell that it's hot. You need a thermometer, however, to tell exactly how hot it is. A thermometer tells you the temperature. Temperature is a measurement that shows how hot or how cold something is. Do you really need to know the temperature to tell if something is hot or cold? Experiment 6. Taking the temperature. You will need various materials with one smooth surface larger than the size of your hand. In parentheses, wood, cardboard, glass, metal, plastic. Liquid crystal thermometer card. in parentheses, available at a pet shop, a pet store. Pencil, paper. Set all the materials so that they are not in direct sunlight or near a light source. Place your palm flat on the surface of each material. Which ones feel warm? Which ones feel cold? Arrange the materials in order from warmest to coolest. Now, place the thermometer on the material that felt the warmest. Wait until the temperature no longer changes. Write down the temperature of the material that felt the warmest. Do the same with the other materials. What do you notice about the temperature of all the materials? Were you surprised to find that all the materials have the same temperature? So why did you feel materials feel warm while others felt cool? So why did some materials feel warm while others felt cool? Metals feel cool. Remember that metals, such as copper and iron, conduct heat. When you touch metal, it conducts heat away from your hand. Heat keeps flowing from your hand to the metal. Because heat keeps leaving your hand, the metal feels cool when you touch it. Even though it has the same temperature, wood feels warmer than metal. Unlike metal, wood does not conduct heat. When you touch it, very little heat flows from your hand to the wood. Because very little heat leaves your hand, the wood does not feel as cool as the metal. On a hot summer day, you may have gone to a beach near the ocean or a large lake. Even before you went into the water, you felt cooler than you did at home. Why is it always cooler near the water in the summertime? Experiment 7. Absorbing heat. You will need 2 large foam cups, water, soil or sand, lamp with incandescent bulb, in parentheses, optional, thermometer. Fill 1 cup with water and the other with soil or sand. Place both cups in direct sunlight or under a lamp for several hours. As the water and soil take in heat, their temperature should rise. Measure the temperature just beneath the surface of the water, then measure the temperature just beneath the surface of the soil. Which is warmer? Land takes in or absorbs heat much more quickly than water. This is why the soil should have a higher temperature than the water. However, once water has absorbed heat, it holds onto it longer than land does. In other words, water does not give up heat easily, so the air near water does not get as hot as the air in inland areas. This is why it's always cooler at a beach on a hot day. How hot can it get? Experiment 8. Warming Earth. You will need measuring cup, 2 identical small glass jars, plastic bag, twist tie, lamp with incandescent bulb, in parentheses, optional, thermometer. Pour the same amount of cold water into each jar. Use the thermometer to make sure that the temperature of the water in both jars is the same. Wrap 1 jar in a plastic bag. Seal the bag with a twist tie. Place both jars in direct sunlight or under a lamp for 2 hours. Remove the jar from the plastic bag. Measure the temperature of the water in both jars. Which is warmer? Heat from the sun was absorbed by the water in both jars. Heat from the water in the jar was not sealed. Could it escape back into the air? Heat from the water in the jar that was not sealed could escape back into the air. However, heat could not escape as easily from the water in the jar that was sealed. Heat then stayed inside the bag, making the water warmer. The same thing may be happening to Earth. Homes, industries, and cars have been burning more and more fuels. All of this burning releases gases into the air. These gases collect in the atmosphere. These gases act like the bag that cover the jar. They keep in the heat the Earth receives from the sun. This heat may be making Earth warmer than it should be. This is called global warming. Heat is a type of energy that can be released, absorbed, conducted, and measured. Heat is used by power plants to produce electricity. On hot days, heat may build up inside our bodies. To get rid of it, we sweat. Heat may also be building up on Earth. If we cannot get rid of this heat, then Earth may get warmer and warmer. Scientists are not sure how this could affect life on Earth. Fun with heat. You learned that water can absorb heat from the sun. Water can also absorb heat from a candle flame. See how you can use this fact to teach your family and friends something about heat. Experiment 9. Blowing up a balloon. Blow up one balloon and tie it closed. Pour a quarter cup of water into the other balloon. Then inflate the balloon and tie it closed. Ask an adult to light a candle while you hold the balloon in the air. Have the adult hold the candle under the balloon. The flame should touch the balloon. What happens to the balloon? Now have the adult hold the candle so that the flame is right under the water in the other balloon. What happens to this balloon? The balloon with no water should burst. Heat warms the balloon and weakens it. The balloon becomes so weak that the air inside breaks open the balloon. The balloon with water should not burst. The water absorbs the heat from the flame. The balloon remains strong enough to keep the air inside. Meet the author. Salvatore Sozzi is a science writer who lives in East Hampton, New York, with his wife Patty. He was a high school biology and chemistry teacher for almost 30 years. As a teacher, he always encouraged his students to perform experiments in order to learn about science. During the warmer months, he gets relief from the heat by sailing on the water in his sailboat. That's all. That was my reading of experiments with heat. Thanks for listening.